Okay. Is the screen is visible?
Yes, sir.
Okay. So in the previous class, due to some TPU session, we have stopped at the middle of the explanation of this three-phase electrodynamometer power factor meter. So as comparing with this three-phase electrodynamometer power factor meter with single-phase power factor meter, so there is some differences are there. That differences is here. Instead of single phase, we have used three phases here now. Three lines are we have used 1, 2, 3 here now. From 1 to 2 and 1 to 3 we are going to use. But for the single phase, we were connected only for the phase and neutral here over there. Okay. And second thing, here also two fixed coils are there here, and two moving coils are there. Identical moving coils are attached to the spindle. Spindle is attached to the pointer. The pointer, it is going to indicate the value of the measuring value, that is called through a calibrated scale here now. Okay, same thing we are using here now, but while the single phase, the coil A was connected to the resistive load and coil B was connected to the inductive load. Here both are connected to the resistive load only here now. Both are connected to the resistive load only here. So the coil B, A and B, the difference between this one, in the meter we are taking the X angle as a reference value here now. This one as a reference value, and the pointer, whatever this one, it is already there here, that is called deflection. Theta we are going to call that one here now. So from this theta to this angle difference is 60 degrees there. From coil A to coil B, again 60 degree angle difference is there. So the total angle of deflection for the coil B is theta plus 60 plus 60 here. So the coil B is deflected 120 plus theta degree away from the reference plane here. Like that we have to consider. So we'll tell that one. And the fixed coil, in between the fixed coil, we are going to keep these moving coils, which are also connected to the same supply of the fixed coil here now. So because of this one, the force will be produced. That force which will start to produce to rotate the pointer that is connected to the spindle over here. So that we are going to consider. So based on this, we have to draw the phasor diagram here now. So see here. So first I will consider the current supply will start from phase 1. That is, it will come here now. See here, one junction we have taken here now. This is a fixed coil here now. First we will give the supply to the fixed coil. Both the fixed coils are connected here now. Connected. And later we have provided the terminals for the load here now. We have provided the terminals to the load here now. It may be used for the this star load, delta load, whatever it may be, but the load should be balanced. It should be applicable for balanced load only here. Balanced load means the R load, Y load, and B load all should be equal to same only. The load should be same. On that condition, we are going to, it is going to apply over there. So from the supply we have taken for the coil A, we are going to consider the coil A. The current will start to flow here. Okay, where it went? Okay, like this. The supply will come here now. Here the coil A is there. Coil A connection, it will go here. Through this resistance value, will go to the 2 here now. So the voltage applied between this one, we are going to consider as V12. We are going to consider as V12. We are going to consider here now. V12. Okay, and it is, so the current flowing through this one is IA here now. IA is this V12. It is connected to the resistive load or inductive load. It is connected to resistive load or inductive load, coil A. Is it audible? Here the resistance we are going. Whenever I will ask the question, automatically it is going to disconnect. I don't know what is happening here. Anyone have the control of this internet? Is it audible?
Yes, sir.
Okay. Where I stopped, this coil A is connected to line 2 here now. The voltage applied between 1 to 2, that voltage we are going to call as V12. So the V12, it will go to the coil A through a resistance to the, this is second phase, that is. Okay. Very intelligent persons are there. I asked any one of you have the control. Sunil, roll number 34. Roll number 34, what you are doing? Roll number 34, unmute please. Sunil Sule. Roll number 34. Unmute please, otherwise I will remove from the meeting. You don't attend my class at all. You can discuss with HOD and you can come back. I will remove roll number 34. Sunil Sule, once again I am asking you, you have to unmute and give response for my call. This yellow line you have written, I know that one. It is everything is under recording only. Is it visible? Yellow line is visible or not? All of your other students?
Yes, sir.
These people left the meeting. 34:18. Roll number 34. Is it audible now? 34. Just now he has joined the meeting. Yes, Sunil.
Yes, sir.
What you have did? Why you have drawn this yellow line? You tell me first.
नेटवर्क प्रॉब्लेम होता है.
नेटवर्क प्रॉब्लम हो तो ऑटोमेटिक यूज हो जाएगा.
हाँ सर.
Okay, leave it. So the current flowing through the 1 to 2 phase, that is V12, we are going to call that voltage between phase 1 to phase 2, the line 1 to line 2, that is called V12, and it is connected through a pure resistance here now. So the current IA is in phase with V12 here now, is in phase with V12 we have to draw. First what we have to do, see here, V1, V2, V3, according to our three-phase supply principle, here all the phases are this V1, V2 and V3. All are divided. Total circle, what is the degree of circle? Total how much degree is there for circle?
360.
360 degree. How many phases are there? 1, 2, 3, 3 phase supply we are going to use. 360 divided by 3, how much it is? 360 degree divided by 3, how much it is? 120 degree here, no? So each line voltage, that is line voltage V1, we are going to call V1. This is V2 and this is V3 here. Now the line voltages are 120 degree apart from each other here now. 120 degree apart from each other here now. So this one I will consider as V1, and this one I will consider as V2, and this one I will consider as V3 here now. So from V1 to V2, it is 120 degree. V2 to V3, it is 120 degree. Again, V3 to V1, again 120 degree is there. So 120 plus 120 plus 120, it will give 360 degree here. So this is 120 degree of fault we are going to call here. But the V12, this V1 plus V2 equal to V12, we are going to call that one here. So for the V12, I am giving the supply in between voltage of V12 here now. So the current is going from the V1 here now. So here, so this one I will consider as positive V1 minus V2 here now. So V12 equal to V1 minus V2. The combination of voltage V1 minus V2, it will give the V12 here. So here the positive V1 is there. This is positive V1. So where is the V2? V2 is here now. So what we have to draw? We have to take the minus V2 here now by extending this one into reverse order. This will give minus V2. Yeah. So V12 is V1 minus V2. So combination of this one, it will give the V12 value here now. That is called V1 minus V2. We are going to get, that is V12 value here. And this one, the total V12 voltage, we are going to call that one. So IA is in phase with V12. So this I will consider as this one as IA here now, which is in phase with V12 voltage here. Same thing we have drawn in this phasor diagram here. In this phasor diagram, we have drawn this one. Same diagram we have drawn here. Similarly, for this is V12 here now. See, I will erase all the things. I will explain once again. Listen here now. First, we are considering V1 and we are considering V2 and we are considering V3 here. All three lines are this line voltages V1, V2, V3. These are 120 degree apart. Yes? These
Yes,
lines
sir.
are 120 degree apart are there. Next, what we have to do, the V12 here now, I told this is V12 equal to V1 minus V2 we have to consider here. Minus V2 we have to consider. Here what I will do here, V2 is there. So the minus term I have to extend in the reverse order, that is called minus V2 will get here now. Here V3 is there, I will extend in the reverse order, that is called minus V3. Here V1 is there, I will extend that one in the reverse order, that is called minus V1 here now. Minus V1 also we can draw here now. Minus V1 here now. So the current flowing through the coil A is because of V12 voltage here now. So V12 is V1 minus V2. Here the V1 is there, here V2 is there. The summation of this one, it will give the V12 value here now. So the total V12 value is this one, V12 value it is going to give here. V12 equal to minus 2V2 also we can write, or plus 2V1 also we can write. Both are same only. This V1 and again this V1 here. V1 plus V1 we can write that one, or 2V1 also we can write here. So the V12 voltage is applied to the coil A here now through a resistance. So current flowing through the coil A, which is in phase with V12. So I will draw the IA current here now, which is in phase with V12 here. It is in phase only now. So this is for one here. Second one, for the coil B, the current will start from 1 to here. The coil B is there. The coil B, it will go and it will go to the resistance and it will go to the third point here. So the voltage applied from 1 to 3 here. From 1 to 3. So what is the V13 equal to now? See, previously we have discussed V12 equal to V1 minus V2. Now what do you mean by what is the formula for V13?
V1 minus V3.
V1 minus V3 here now. Same thing we have to draw here now. V1 minus V3. Here the positive V1 is there. So V3 plus here. So extending that one minus it will get here now. So the summation of V1 minus V3 that will give the V13 here now. That is called the extended path. I will draw here now. That is V13 here now. So the V13 is applied to the coil B. The current flowing through the coil B is, what is that one? Which current it is? IB here, no? It is connected to the resistance in series with that one here, no? So the current IB is in phase with V13. IB is in phase with V13 here, no? So this one is V13. So the current IB is in phase with this V13 here now. Okay, so similarly we can try for the I13, only 1 to 2, 2 to 3 is there. That much is enough here now. That much is enough. And the load we have provided the terminal here now. So the angle between main V1 to V1 and I total current we are going to consider as here. Actually what will happen? So V1 minus V2, V1 plus V1 plus V2 plus V3 equal to V total V we are going to call. So V1 equal V1 and the voltage, sorry, phase angle between the voltage and current we are considering as, that is called phi here. So this is the total current I we are considering here. So three phase current, that is called I, we are going to consider here now. That is V1 and current I, the angle between the phase angle between the voltage and current is phi here now. Based on that, see here, previously what we have considered, we have considered V1 as a reference we have taken here, and V2 we have drawn here, V3 we have drawn here now. So we have to identify here V1 to V2, how much angle is there? V1 to V3, what is the angle difference? V1 to V3, how much angle is the difference?
120.
120. Here V2 I will make into middle of the V1 and V3, it will come here now. So here we can write this is 60 degree and here also 60 degree. Yes?
Yes.
60 degree here now. The V12 we are taking at middle means this 60 is again divided into 30 plus 30. Here also 30 and here also 30. Yes, this part is 30, this part is 30. Can write like this. 120 is divided by 2 is nothing but 60. 60 is dividing by 2 means 30 plus 30 we are going to get here now. So the angle between this, whatever the V1 to IA and V1 to IB, that is called 30 degrees is there here now. So this is 30 degree and this is 30 degree here now. So once we have to identify the current angle between I and IB, what is the angle between I and IB? Can anyone tell? This is 30 is there, total angle is 30, and from here to here that is called phi is there. I am asking what is this angle here now? Anyone can you tell me? Yes. I'm asking to you peoples only. See here, I will tell from this angle is 30 degree. This one is 30 degree. Here it is phi is there. I am asking what is the angle of this one? I to IB, what is the angle here?
30 minus 5.
30 minus 5.
30 minus 5. Total 30 degrees there. So this is 5 we have to minus. Then we are going to get to the I and IB here. Now why I am asking means while writing the torque equation of for the coil B here, two torques will be produced here. Now one will reflect on coil B, another reflects on coil A here. Now so while writing the torque equation, it is the KVI product of voltage and current and the angle between the I and IB here now. So the cos 30 minus 5 we are going to get here now. And for the torque on coil A, that is called cos 30 plus 5. I to IA we have to consider here now. So similarly for the sine we have to use this one. So for the A coil sine theta plus 60. For the B coil sine theta plus 60 plus 60 is nothing but theta plus 120 we have to write down here now. The same equation I will show here. Before that one, we'll read the explanation. Now this meter is only useful for the balanced load. Whatever the terms we have provided here now, load, it may be connected star connection load or delta load, whatever it may be, but the load should be balanced over there. And two moving coils are placed that the angle between the plane is 120 degree here now. Two moving coils are there. So the total angle between that place is 120 degree here now. They are connected across two different phases of the supply. One is connected to 1 and 2. Another one is connected to 1 and 3. Both the coils are connected here now. See here. This is connected for 1 and 2. This is connected for 1 and 3 here now. Both are connected. They are connected to different phases of the supply circuit. Each coil has a series resistance here now. Coil A and coil B both has a series resistance here now. So there is no necessary for the phase splitting by artificial means, since the required base displacement between the current IA and IB in the two moving coil can be obtained from the supply itself here. Now, whatever the displacement is there, it is going to get from the current flowing through the IA and IB, it is going to get from the supply voltage itself here now. And the voltage applied across the coil A is 1 and 2, that is called V12 here now. So the current flowing through the coil A is, that is called IA here now, and through resistance it is going to flow here now. So IA is in phase with V12 here now. Same thing they have written here now. Voltage applied across coil A is V12, and as its circuit is resistive, the circuit is resistive only, current IA is in phase with V12 here now. V12 is 1 and 2. The phase 1 and phase 2 supply is given to the coil A here. Now, current flowing through the coil A is IA, which is connected to the resistive load, or the circuit is resistive. So IA is in phase with V12. Similarly, V13 we have to consider here now for the coil B. So the coil B is also resistive here now. So current flowing through the coil B is IB. IB is in phase with V13 here. That one we have to discuss here now. Now comes for the equation here now. Directly I go for the tasks acting on coil A here now. Acting on the coil A, I will write here now. So TA is, that is K is the proportionality constant. V1 is nothing but voltage, current. So the mutual inductance, maximum mutual inductance between the coil A and coil B, that is called M max. We are going to call that one. So by considering for the coil A, cos 30 plus phi, I told that one from this phase angle here now. What is the angle between IA and I? What is the angle between IA and I here now? Anyone can tell? Angle between this IA to I here now. Is it audible or not?
5 plus 30 degree.
30 plus 5 or 5 plus 30 here now. So by considering this one as a triangle here now, so IA equal to cos 30 plus 5 we can write. Cos 30 plus 5. Like that we have to write in the based on the triangle methods, which is the real part, imaginary part. For the real part, cos is nothing but real part, sine is nothing but imaginary part. Like that we have to use. For the from the phasor diagram, we'll get the real part. From the whatever the circuit diagram, angle of deflection is there, that is imaginary part, that is called sine, we are going to get here now. So cos 30 plus 5 we are going to use here now. So this one we have considering as a reference. This is the reference angle we are considering here now. So what is the difference between the angle of deflection here now from the reference to coil A here? From here to here it is theta is there. From here to here it is 60 is there. So sine 60 plus theta we can write. Yes?
Yes, sir.
Sine theta plus 60 we have to write. Same thing we have written here now. So TA equal to K VI M max cos 30 plus 5 plus sine 60 plus theta here. That is we are going to call here. So V1 is the, that is the line voltage that is converted into phase, that is called root 3 V we can write here now. So that we have connected here now, root 3 K VI M max here, and same thing we have written sine 30 plus 5 plus cos theta. So similarly, any one of you can here only I will tell that one. TA we have written as, where I have to write? TA we have written as, that is here I will write. TA equal to K V1 I M max MM I will write here now, cos 30 plus 5 into what is the value? Sine what is this one here now? Theta plus 60, that is called sine theta plus 60 only I will write here. Similarly, any one of you, can you tell me the formula for TB? torque equation for the coil B here? No. Any one of you. I will write this one K, V1, I and M as it is here. No. Here the cos also I will write as it is here. No. Cos also I will write as it is. What is the angle between the phase angle between the current I and IB? I and IB. What is the angle here? What is this angle?
30 minus
30 minus 5. Very good. 30 minus 5. 30 minus 5. Next, sine also I will use here. No. What is the from reference plane to the reference of B? What is the angle here? No. Theta plus from here to this angle, from here to here it is. So what is this angle here? What is this angle?
120.
Only 120? From here to here, theta is there. From here to here, 60 is there. From here to here, 60 is there. 60 plus 60, how much?
120.
120 plus this theta. So we can write theta plus 120.
Yes, sir.
Theta plus 120 here now. So like that, we got the equation here now by, we know the formula of TA equal to TB. From the starting onwards, we understood that the deflecting torque equal to controlling torque. Based on that, two torques are produced means here now. So one is, there is no spring control method here now. Both are opposing to each other, like that we have calculated here. So in the previous also in the single phase, we have shown that one. So by considering torque TA equal to TB, then what will happen? This, by rearranging this equation, all the equations, by applying some mathematical equation, we are going to get theta equal to 5 here now. What do you mean by theta? Anyone?
Angular deflection.
Angular deflection. And phi is? Phi is what? The phase angle between voltage and current. So cosine of this one, it is, we are going to get that as a power factor here now. So by considering this one, same thing they have written here, and the formula also I will show here now. See here, solving the above expression, we have to get theta equal to 5 here now. So this is the last here now. So theta is the angular deflection of the pointer from the plane of reference is equal to the phase angle of the circuit here now. So phi is the phase angle here now. Theta is the angular deflection. So angular deflection is the equal to the phase angle here now. So for the three-phase power factor meter gives indication which are independent of waveform and frequency here now. For this three-phase power factor, it is independent from the waveform, whatever the frequency of the supply it is. None of that. It is nothing but it is independent of that one. How much, whatever you can apply that one. Since the current in the two moving coils are equally affected by any change of frequency here now. So for the measurement of power factor in three-phase unbalanced system here now, see here, whatever we have discussed, that is called for the balanced system. For the unbalanced system, a two-element power factor, that is where two sets of fixed coils and two sets of moving coils we are going to use, has to be used here now. So same thing we have used here now already, but if the balance rate is there, we are going to get the exact answers. So for the unbalanced conditions, one set is there here now, fixed coils. Two sets we are going to use, two fixed coil set, two moving coil sets here now. 2 into 2, 4 moving coils, 4 fixed coils we are going to use for the unbalanced, where two sets of fixed coils and two sets of moving coils mounted on the spindle here now. So whatever the things we are using, double they are going to use for the unbalanced condition here now. Actually the system is balanced only, then only the load factor, whatever the power factor, we are going to get easily here now. Otherwise in your houses also, if the load variation occurred, if the residential building is the commercial work is going on, the load suddenly you have applied the high load for one phase, a high low load for the another phase, that is the power factor will impact on that one. Some industry purpose, they are going to get the fine for that. So The electrical power system, it is going to prepare for the balanced condition only. So it completes for the power factor measurement by electrodynamometer. Same principle, the power factor measurement we have to do by using moving iron system. If we have used a moving iron instrument, how to calculate the power factor here now? That is called three-phase moving iron power factor instrument here now. We have to calculate power factor here also, but that is by using the moving iron instrument we have to calculate here now. Is the screen is visible? Three-phase moving iron power factor. Is the screen visible?
Yes. Yes.
Okay. See here, I have shown here two diagrams are there here now. This is the circuit diagram. This is the actual instrument picture we have considered here. That is not complete picture here now. See, I will explain this one and you can check, compare with this here now. See here, 1, 2, 3. Three phases supply we are using here now. Three-phase supply. 1, 2, 3 here now. Three-phase supply. Three lines are there here now. So three-phase supply we are using here now. Here, A1, A2, A3 here now. Three fixed coils are there. These all three coils, A1, A2, A3, we have fixed apart from 120 degree. From A1 to A2, 120 degrees there. Yes, angle is A1 to A2, 120 degrees there. A2 to A3, 120 degrees there. And A3 to A1, 120 degrees there. Yes. So we are using three fixed coils here now. A1, A2, A3 here now. These coils are fixed by maintaining 120 degree apart from each other here now. They are fixed here now, 120 degree apart from each other. And from the phase 1, we have taken the supply for A1. From the phase 2, we have taken the supply for A2 here now. And from the phase 3, we have taken the supply for A3 through a current transformer we have used here now. The CT we have used to give the supply here now. We have taken the supply for A1, A2, A3. This is the whatever the fixed coil here now. This is the working of the construction of fixed coil here. This is outer side, it is over now. Whatever the inside inner side is there, here, see here, this one, whatever we are going to ask this one, this is a spindle, actually we are going to call that one, which is connected to the damping vanes are there, pointers are there, and some another here. See, V shape is visible here. This is V shape. Yes. This one.
Yes, sir.
This V shape is vanes we are using here. No, two vanes we are going to use. One side, this side, and 180 degree apart from that another side we are going to use here. So here, two vanes we are going to use on the both the sides here. No, and that vanes are connected to the iron cylinder here now. This is the iron cylinder is there here now. This one, whatever it is there, that is the iron cylinder here now. So this iron cylinder is surrounded by a coil here now. One more fixed coil we have used here. That coil is called coil P here now. This is a coil P is also fixed here now. What is the title here now? What is this one? Moving iron instrument. So this vane is nothing but iron material only. Moving iron instrument, all of you have studied, that is attraction type, repulsion type. Again, repulsion types are two are there, radial, coaxial. Yaad aa raha hai kya? Radial type, coaxial type. All of you remember that one or not? Yes. In this operation, what we are going to do, there is no rotation of the coil here now. Here, whatever the iron part is there, it is going to rotate here now. For that reason only the name came here now, moving iron here now. Whatever this connected, the cylinder is connected to the spindle. That spindle is connected to the pointer. If the vanes are these vanes and these vanes, two vanes are connected to the cylinder here now. So if the magnetic, because of the force produced, then what will happen? This will start to rotate or move away, moving. Then it is connected to the spindle. That spindle is connected to the pointer. So obviously it is going to show some value here. See here, this part only this part only, rotating part, we have drawn the diagram here. The rotating part diagram only, it is there here. I will tell you how it is going to operate here. See here, this is the spindle I have told here now. So this part you can consider as spindle here now. Inside that one spindle, which is this complete part. This is also spindle, which is connected to the pointer. Just assume that one here is connected to the spindle, and it has also some damping vanes to produce the damping force. We are going to use damping vanes are there. Those are also connected to the spindle only. Just imagine that. Next, what will happen? You just consider this is the cylindrical cylinder, iron cylinder we are going to call it. This is the iron cylinder, whatever this part we are using here now. Both sides I am explaining. Listen carefully. This is the cylinder here now. And here one vein is there. Here one vein is there. So this is one vein and another vein is connected to another side here now. Two veins are connected to this system here. And these veins are, and iron cylindrical is placed in between the, which is that is called, that is coil P here now. This is the fixed coil. P is there here. Here and here we have used a fixed coil here. Fixed coil we have used here now. So this is the construction and operation. I told that one moving iron, the veins will going to rotate that one. So angle of deflection we are going to get again here. That is called 5 only. Our aim is power factor meter here. So no need to draw the circuit diagram, phasor diagram. I will tell that one. Before that, whatever I have explained just now, that part we will discuss here now. A1, A2 and A3 are the three fixed coils are there. Same thing I have told. A1, A2, A3 are the three fixed coils are there with their axis displaced 120 degree apart from each other and intersecting on the center of the line of the instrument here now. See the center of the line of instrument 120 degree apart each are there. So these three coils are connected respectively to a lines 1, 2 and 3 here now. So through a current transformer, see this coil A is connected to the line 1, coil 2 is connected to the line 3, coil 3 is connected to the line 3, coil 2 is line 2, coil 3 is line 3 here now. Through a current transformer we have told here now. Usually current transformers are used for the purpose here. Here one more coil we have used in the inside part, that is called P is a fixed coil connected in series with high resistance across one pair of lines, say 2 and 3 here. See here, this is the coil P is connected here now, and it is also connected to the resistance here now. In between 2 and 3 here now, it is started from 2, the current will flow here now and it will come back here now. So because of this, the veins will get magnetized, magnetic effect will be occurs over there. So it is going to start to rotate over there. So there is an iron cylinder C inside the coil P here now. In between this coil P, this is the coil P, here the iron cylinder is there. Like that, this is the coil P, here the iron cylinder we have placed here now. So two sector shaped iron veins V and V are fixed on the cylinder here now. See, this is the cylinder, this one vein, another vein fixed on this iron cylinder. We have shown the actual picture here now. This is vein 1, vein 2 here now. Two veins are fixed over there. So two veins are 180 degree apart. So out of 360 degree, 180 degree apart, they are connected here now. The spindle also carries damping vanes and a pointer here now. So the spindle, which is the spindle which is connected to the damping vanes, as well as the pointer is also there here now. So the operation is when the coil P and the iron system produces the alternating flux here. Whatever the iron system and coil P is there, it is going to produce the AC flux which interact with the fluxes produced by the coil A1, A2, A3. Then it is going to cause a moving system to take up the position here now. Whatever this coil P is there, it is producing the alternating flux which is intersect with the A1, A2, A3 fluxes over there. So which is this one, it is going to cause the moving system to rotate or move up over there here now. This causes the moving system to take up an angular position determined by the phase angle of the circuits over there. Current we are going to call here now. The angle of between voltage and current, based on that, it is going to take up a position here now. So the theory of the moving iron instrument may be developed in similar manner to that of electrodynamometer type here now. The operation working principle is same like that of whatever we have discussed the electrodynamometer here now, but we are going to use the cylinder is connected to the vanes V and V here now, which is magnetized, and the current IP in the coil P, which is in phase with the proportional to the line voltage. The connectivity is coil P is connected to the resistive load or inductive load here now. See here, this is the coil P is connected to the resistance here now. So the current IP is in phase with the voltage. We can call that one here now. The is in phase with the voltage system here now. Then if the effect of hysteresis and eddy currents are ignored, the iron cylinders here. Iron part we are using means the iron losses all of you have studied in the diploma itself here. Once again, I will tell in the transformer also, you will tell that one. So the iron losses are constant losses, we can call that one here now. Especially the iron losses or core losses, we are going to call that one. Iron losses are core losses, which is present in the core material here now. If we are using a iron part, then the eddy current and hysteresis losses are there. But the iron cylinder and vanes we are using here now, and the coil P also we are going to use here now, which is electromagnetically rectangular moving coil pivoted within in the A1, A2. By intersecting that one, we can reduce that one. We can tell that one. If the effect of hysteresis and eddy currents are ignored, we are going to ignore that one. Then the iron cylinder and vanes and P are equivalent electromagnetically. Whatever the cylinder is there, vanes are there, and the coil P are equal in magnetically. We are going to call that one here. So the equation is there? Yes. No. So same circuit diagram can draw here now. The phasor diagram here now. V1, V2, V3. 120 degree apart we have taken here now. So the voltage between 1 and 2, that is called V12. So we have to extend the minus part of this one. Negative part we extend here now. V1 and V12 is V1 minus V2 here. I'll write here. If you have in the, regarding this, you can ask me. I will tell that one V1 minus. I can remove this one and I will draw the diagram also once again. If you are having doubt, V2 equal to V2 minus V3 like that. V2 minus V3 here now. V31 equal to V3 minus V1. V3 minus V1 can draw here now. See here, V12 is V1 minus V3. V23 is V2 minus V3. And V31 is V3 minus V1 here now. We have to draw first V1 and V2 and V3 120 degree apart from each other. Then in the reverse order, by extending that one, minus V2 will get that one, minus V1 will get that one, minus V3 we are going to get here now. So to get the V12 voltage, we have to extend that one for the intersecting of V1 minus V2 here now. So next similarly, V2 minus V3 we can intersect here now, and V3 minus V1 can intersect here now. So the current flowing through the phase 1, phase 2, phase 3, we can call that one the angle between the voltage and current, that is called phi here now. V1 and I1, that is called phi. V2 and I2, that is angle between phi. V3 and I3, that is angle between phi. So total V and I, that is called V and I, whatever the angle between is there, that is called phi. We are going to call that one here now. Phi, that is called angle between that is phi here now. That is called phase angle of voltage and current here now. So this is the phasor diagram of that one here. So the operation is same like that one, means again here the theta, whatever the angle of deflection is there, that theta equal to phi only we are going to get here now. Theta, the angular deflection, equal to the phase angle between the voltage and current here. In the similar way, in the similar manner, we are going to discuss the single phase moving iron power factor meter here. This is for the 3-phase. For the single phase, I will ask once again, you peoples, just observe the diagram here now. This is for the 3-phase. Same diagram we are going to describe for the single phase here now. Here 3 supplies are given, 3 lines are we have given, line 1, line 2, line 3. The construction is same only here now, but the supply we have given, 3-phase supply we have given. If we have applied for the single phase, how it is going to operate, we are going to discuss in this diagram here now. The diagram is visible?
Yes, sir. Yes.
What is the difference between the three phase and single phase? Anyone, can you tell me? Here, by seeing the diagram itself, you can tell. The same instruments we are going to see here. The electrodynamometer type power factor meter, that is also single phase, three phase we have considered. Moving iron type, again we are discussing for the single phase and three phase. Yes or no? Yes. See here, instead of using three phase, we are using single phase here now. One phase, one neutral. Okay, one phase, one neutral. We are going to use here now. This is called phase, and this is neutral here now. This is phase and neutral here now. See here, the A1 is connected from phase to coil A and through A in series with resistance here now. So the coil, fixed coil A1 is connected to the which load it is? Tell me first. Resistance? Yes or no?
Yes, sir. Yes, sir.
So coil 2, that is A2 is connected to the, that is inductive load, it is connected here now. And the coil A3 is connected to the capacitive load, it is connected. So the A1 is connected to the resistance, A2 is connected to the inductive, A3 is connected to the capacitance here now. So if we are considering I1, we are taking as a reference, I1 we are taking as a reference here now. I am not considering as I here now. This is I1 here now. So total angle between the I2 and I3 you can consider as, because one is inductive load, another one is capacitive load here now. So here I can consider the I1 is in phase with the voltage that is called V here now. We can call that one. So see here the I1 is there, here the I2 is there, here the I3 is there. Okay. So by extending part of this one, I1 and this is I2 and I3 here now. So extending part that is called the I3 and I2 we are considering here now. So the angle of, by taking the, considering the reference as I1 here now. So we can draw here I1 and the total angle is I2 and I3 120 degree. So this is inductive load and this is capacitive load. So 60 degree apart, that is lags I2, and I3 60 degree leads or lags here. Which one is, I will give the question choice to you people. In the anti-clockwise direction, you consider here now. So I will consider as I1 as a reference here now. By comparing with I1, by seeing this diagram, which current is lagging, which current is leading? Anyone, can you tell me? See, all the three currents are 120 degree apart. We can consider that one after reversal and all the things. In the later, I will tell that one. Okay, in the tomorrow class, I will tell difference, how it is going to reverse. The reversal takes place means how it is going to 120 degree and all the things. Okay, now you tell me, by seeing this diagram, which current is lagging, which current is leading? By considering I1 as a reference. Anyone?
I3 is leading and I2 is lagging.
Come once again.
I3 is leading.
I3 is leading. How much angle? Yes. Any others, students? 1-2 persons are giving the answer. Other people, you have to. Interaction will give more knowledge than listening. Remember that one. Whenever you will start to interact, you will get the more knowledge. Even someone asked the question means they are getting that one point. Will not understand anything, they will not ask the questions. Leave that one. In the anti-clockwise direction, I told, by considering, suppose I will consider here the I1 is there here now. Okay, I1 is there here now. So in this direction, we'll consider here now. in this direction we are considering here. This point I1, and here I2 is there. Here I2 is there. And here I3 is there. So which one कौन सा current आगे है, कौन सा current पीछे है I1 से compare किया तो?
I2 is leading and I3 is lagging.
I2 is leading, I3 is lagging. The arrow mark is in this direction, madam.
I3 is leading, I2 is lagging.
Very good. So from here we are considering this is the reference point I am considering here. No, I am I1 here. No, so मेरे से आगे कौन है I3, मेरे से पीछे कौन है I2 here. No, so I2 is lagging I1, I2 is lagging I1, and I3 is leading I1. Like that we can see here. So we'll stop here only, and we'll discuss in the tomorrow class. We'll discuss about this one. Just a minute. Rule number 1, 2, 3, 4, 5, 6, 7, 8, 9. Directly. 6, 7, 8, 9. Rule number 9, 11, 13, 15, 17, 19, 20, 21, 22, 25, 27, 28, 29, 30, 31. Very good. 32, 33, 34, 36, 37. So these are the option numbers. So attend the classes regularly. You have very less time. So don't skip the classes, and you have to practice. See, nowadays the offline sessions are going on. Most probably you may have the offline exam. For that reason only you have to do the preparation. Actually circular has not came, but then also you have to prepare for the offline. Then online will become easy for you people. Note this point. Okay, we'll stop here only. We'll continue in the next class.